Alright, so the branches are the actual hyperbola graph. Transverse axis contains the vertices, and if extended, the foci. Vertices are the endpoints of the transverse axis. The conjugate axis separates the branches of the hyperbola, and the co-vertices are the endpoints of the conjugate axis. Just like with the previous, my A are my vertices, my B are my co-vertices, and my C are my foci. So if you look at the picture on the right, you see a horizontal and a vertical. So we have two equations that we go by. The first is for the horizontal. It's x minus h over a squared minus y minus k over b squared equals 1. So just like always, our center is at hk. My vertices are at h plus or minus a comma k. My co-vertices are at hk plus or minus b. My foci are going to be at h plus or minus c comma k. And my asymptote is going to be y minus k equals plus or minus b over a parenthesis x minus h. Alright, so for my vertical ellipse, my center is also hk. This is going to be h comma k plus or minus a. This is going to be h plus or minus b comma k, and then my foci are going to be at h plus or minus hk plus or minus c. Alright, my asymptote formula for this is y minus k equals plus or minus a over b comma x minus h. Alright, to find the constant difference, so this is our x1, y1, x2, y2, x3, y3. So it is the square root of x1, which is negative 5, minus x3, which is 4, squared, plus y1, which is 0, minus y3, which is 0 squared, plus square root of x2, which is 5, minus x3, which is 4, squared, plus y2, which is 0, minus y3 squared. So this guy here is negative 9 squared, plus this guy here is 1 squared, so we get 9 plus 1, which is 10. Write the equation in standard form. So because the vertex is on the x-axis, we definitely know that this is a horizontal. So we're going to go ahead, and this is going to be x squared over a squared. This is your a, this is your b. So 36 minus y squared over b squared, which is 16, equals 1. Now because my vertex is on the y-axis, this is going to be vertical. This is my a, this is my b. So for my vertical, it's going to be y squared over a squared, which is 64, minus x squared over b squared, which is 9, equals 1. Alright, for C, my vertex is at 5, 0, so again, this is going to be a horizontal. Alright, so this should be a negative 8, not a negative. Let's go ahead and fix that. So focus is at 0, negative 8. So I'm going to go ahead and find it. So c squared equals a squared plus b squared. Negative 8 squared equals negative 5 squared plus b squared. 64 equals 25 plus b squared. So b squared equals 39. So this one is going to be x squared over 25 minus y squared over 39 equals 1. Alright, so this one's horizontal. My A is going to be the square root of 49. My B is going to be the square root of 9. So for my vertices, because this is a center is at 0, 0, it's going to be A comma 0 and negative A comma 0. My co-vertices are going to be 0, B and 0, negative B. And because the center is at 0, 0, this asymptotes are going to be at y equals plus or minus b over a, which is plus or minus 3 over 7. Now, the cool thing about asymptotes is once you graph it, I'm going to show you a neat trick. So let's graph this. 1, 2, 3, 4, 5, 6, 7. Let's go ahead and graph our vertices. I'm going to graph those in blue. And then I'll change to red for my co-vertices. My co-vertices are at 0, 3 and 0, negative 3. Now for the asymptotes, especially when it gets harder, when we get to ones where their centers are not at 0, 0, we can graph the asymptotes really easy by creating this hypothetical box. So if we create a box connecting my co-vertices with my vertices, and do it dotted because it's to help you with your asymptotes. So you have to go through all. So when you do that, you actually get to go through your, create your asymptotes because it has to go through your center and each edge of the box. So here's one asymptote. And that one didn't go through the edge so well. But realize that it's supposed to go through the edge a little bit better. Alright, so those are my asymptotes. So the actual graphs of the hyperbola is going through your vertices along those asymptotes. There we go. The yellow is your actual graph to get there. Alright, so let's try the next one. So the next one's definitely going to be vertical, and how we know that is, so this one's going to be vertical, and how we know that is because the y squared comes first. So my center is still at 0, 0. My vertices here are going to be at 0a, so 0, comma 5, and 0, negative 5. My co-vertices are going to be at b, which is 6, 0, and negative 6, 0. And then my asymptotes is going to be at y equals plus or minus a over b, 5 over 6. Okay, so remember that your a is the square root of the first thing you see, and your b is the square root of the second number on the bottom. So let's go ahead and plot our vertices. My vertices are at 0, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Negative 5. Let's do my yellow. Co-vertices we'll do in yellow this time at 6, 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's create that hypothetical box to help us graph our asymptotes. Our center is at 0, 0. Our asymptotes go through each edge of the box and the center. And this is a vertical hyperbola. So the green is the graph. There we go. Okay. All right, so letter C, this one is a horizontal because your x comes first. Your center is going to be at 2, comma, negative 3. Let's go ahead and get that cheat sheet out for our vertices that we did on the first page. I'm going to flip my book over here. So for my vertices, let's see, my A is going to be 4, my B is going to be 7. So for my vertices, it's going to be H, which is 2 plus or minus A, comma K. So 2 plus 4 is 6, comma, negative 3. 2 minus 4 is negative 2, comma, negative 3. My co-vertices are going to be at h comma k plus or minus b. So that's going to be at 2 comma 4 and 2 comma negative 10. And then my asymptote is going to be at y minus k equals plus or minus b over a times x minus h. So that's y plus 3 equals plus or minus 7/4 x minus 2. Alright, so don't worry about that formula so much. Remember our box trick. So first let's go ahead and plot our center. So I'll do that in black. So 2, negative 3. Here is 2, negative 3. Next, let's go ahead and plot our vertices. So my vertices occur at 6, negative 3 and negative 2, negative 3. So that's 2, 3, 4, 5, 6, negative 3, and negative 2, negative 3. My co-vertices are at 2, 4, and 2, 10. So 2, 1, 2, 3, 4, and 2, negative 10. Alright, so let's create our box to help us with our asymptotes, especially because that decimal. Okay, let's create our asymptotes through each edge of the box and that center. And then remember we said this is horizontal, so my branches are going to go here and here. Alright, for the next one, we know that this one is definitely going to be a vertical because the y comes first. Be careful with your center. Your h always goes with your x value, your k with your y value. So my vertex here is going to be h comma k plus or minus a. My a is 3, my b is 1. So that's going to be 1 comma negative 8 and 1 comma 2, negative 2. My co-vertices are going to be h plus or minus b, comma k. So that's 1 plus 1, which is 2, negative 5, and 1 minus 1, which is 0, negative 5. And my asymptote formula is y minus k squared equals plus or minus a over b times x minus h. Alright, so let's go ahead and plot our vertices. Our vertices are at 1, negative 8, and 1, negative 2. My center was located at 1, negative 5. My co-vertices are going to be at 2, negative 5, and 0, negative 5. So if we create our box, and we create our asymptotes, this is a vertical, so this guy goes up here. I didn't do such a great job. Try not to hit that asymptote, but you know, we're working with what we're working with here. Okay. Alright, so parabolas. It's a set of all points in a plane that are an equal distance from the focus and a fixed line called the directrix. The vertex of a parabola is the midpoint of a segment connecting the focus to the directrix. So it says use the distance formula to write the equation of a parabola. So our distance formula is, let's blow this up. So the distance formula is the square root of x minus x1 squared plus y minus y1 squared equals the square root of x minus x2 squared plus y minus y2 squared. So this is going to be my x1, y1. We do not have a x2, and my y2 is negative 3. So when I go ahead and fill it in this formula, I get x minus 0 squared plus y minus 3 squared equals x minus x squared plus y minus negative 3 squared. So because everything's squared, it's kind of cool what gets to happen here. So x squared plus y minus 3 squared equals x minus x is just that, y plus 3 squared. So because all the squared's happening, we're just left with x squared plus y minus 3 squared equals y plus 3 squared. So when I FOIL that out, I get x squared plus y squared minus 6y plus 9 equals y squared plus 6y plus 9. So when I go ahead, I see that we have a y squared on both sides, so we know that that cancels. If I add this 6y to this 6y, I get 12y, and I bring this 9 over, I get 0. So right now I'm at x squared equals 12y. I divide by 12. This is running out of room here. So I get y equals, remember there's a 1 in front of your x squared. Y equals 1 over 12x squared. All right, so for the letter B, this is my x1, y1. This is my x2. I do not have a y2, so we're just going to call that y. All right, so my formula is the square root of x minus x1 squared plus y minus y1 squared equals the square root of x minus x2 squared plus y minus y2 squared. All right, so for here we have x minus 7 squared plus y squared equals the square root of x plus 1 squared. All right, so now we're going to square both sides to get rid of the square root. So now I'm at x minus 7 squared plus y squared equals x plus 1 squared. FOIL the x minus 7, x squared minus 14x plus 49 plus y squared equals x squared plus 2x plus 1. We have x squared the same on both sides. They cancel. I'm going to go ahead. So we're going to isolate the y squared. So I'm going to add the 14x minus the 49, add the 14x minus the 49. So now I'm at y squared equals 16x minus 48. Divide by 16 to get x by itself. So I get 1 over 16 y squared equals x minus 3. All right, so because my directrix is in the form of y equals, we know that this is a vertical parabola. So my focus is going to be 0, comma, p. My directrix is y equals negative p. So if it's negative p is negative 2.5, that means my p is positive 2.5. My formula for a vertical is y equals 1 over 4px squared. So my final answer is y equals 1 over 4 times 2.5x squared, which is y equals 1 over 10x squared. Alright, so letter B is going to be a horizontal parabola, and the reason why we know it's a horizontal parabola is because your focus is p comma 0. So because our p is -6, we can jump right into the formula. X equals 1 over 4py squared, which is x equals 1 over 4 times -6y squared, which is 1 over -1/24 y squared. So x equals -1 over 24 y squared. How to graph parabolas. So first step is to identify the vertex. Then we're going to solve per p. We're going to determine whether it's a horizontal or vertical parabola and the direction of opening. Then we're going to find the focus and the directrix. So I gave you this nifty little cool table here. If you look at it, there's the equation when the vertex is not at 0, 0 like it was in the previous. So horizontal, it's x minus h equals 1 over 4p times y minus k squared. For vertical, it's y minus k equals 1 over 4p times x minus h squared. Still notice that your vertex h goes with the letter x and k goes with the letter y. If p is greater than 0 for a horizontal, it's going to open to the right. P is less than 0, it opens to the left. For a vertical, if p is greater than 0, we're opening upward, and if p is less than 0, we're opening downward. Alright, so example 3, let's identify my vertex. I keep calling it center, but please know that that's what I mean. So this is based on this chart. It's x minus h. Let's go ahead and say this is a horizontal. So my vertex is going to be at 2, -5. Let's go ahead and determine p. So -16 equals 4p. We divide by 4. P equals -4. So because p is less than 0, it's going to open to the left. My focus is going to be at h plus or minus p comma k. So my focus is going to be h plus p comma k. So that's going to be 2 plus -4 comma -5. So that's -2, -5. And my directrix is going to be x equals h minus p. So x equals h, which is 2. Alright, so that's going to be h, which is 2 minus -4. So that's 6. So let's go ahead and plot my vertex, which is 2, -5. 2, -5. Let's go ahead and plot my directrix, which is at x equals 6. 3, 4, 5, 6. And this is going to open to the left. So we're going to go ahead and, there we go. Alright, so for example B, my vertex, x minus 1. Alright, so this is still in the form of a horizontal because the y is not first, the x is first. So my vertex is going to be at 1, 3. Let's go ahead and find the value of p. So 4p equals 12. We divide by 4. P equals 3. So because p is positive, looking back, we're going to open to the right. Alright, let's go ahead and find our focus. Our focus is going to be h plus p, 1 plus 3, k, which is 3, so 4, 3, and our directrix is going to be x equals h minus p, so x equals -2. So let's plot my vertex, which is at 1, 3. Let's go ahead and plot my directrix, which is x equals -2. And this opens to the right. Okay. Last guy, so this is definitely a vertical, and we know that because the y comes first. Be careful with your vertex. Remember that your h value is always with your x, your y value is always with your y for your vertex. All right, so my focus is h comma k plus p, so that's going to be 8 comma 4 plus, let's go ahead and find p. So -2 equals 4p. We divide by 4. P equals -1/2. So I have 8 comma 3.5 for my focus. And then my directrix is going to be y equals k minus p. So y equals 4 minus -1/2. So y equals 4.5. All right, so let's go ahead and plot my vertex. My vertex is at 8, 4. So 8 is here, 1, 2, 3, 4. My directrix is next, y equals 4.5. All right, so let's plot our directrix, which is y equals 4.5. So that was 1, 2, 3, 4.5. So we never talked about whether this opens up or down. P was negative, so because P is negative, it opens down. So there we go. All right, so lighter sound waves collected by parabola will be reflected by the curve through the focus of the parabola as shown in the figure. Waves emitted from the focus will be reflected out parallel to the axis of symmetry of the parabola. This property is used in communications technology. The equation for the cross-section of the parabolic is x equals 1 over 32 y squared, measured in inches. How long should the engineers make the feed horn? Oh, well, the focus. So because it's the focus, 4p equals 32, we divide by 4, p equals 8. So they should make it 8 inches long. Keyword is focus. That helps you find it.